Hello folks, welcome back to my YouTube channel, and we are in the Python basic series for beginners. In this video of functions, we will have a look at recursive functions and lambda functions. So let's start. Recursion is a process in which function calls itself, and such functions are called as recursive functions. So to better understand this, we will take a problem statement to print a factorial of a number. All right. So first of all, what is factorial? Say if I want to find a factorial of number 5, then the factorial of number would be 5 into 4 into 3 into 2 into 1, and that is equal to 120. If the number is 0, 0 factorial is 1, and if number is 1, 1 factorial is also 1. So let's see how we can code this out and write a recursive function to do the same. All right. So firstly what we do is we define a function. We name it as recursive underscore factorial, and we will be taking one integer, that is one number, as a as an input. So we check for a condition. If n is equal to n, we return n, that is 1 itself will be returned. Else we subtract and go on to calculate the product. We subtract 1 and go on to calculate the product. Now in this case, I have taken the number as 5, and I have some logic applied as well. If number is less than 0, so there is no factorial of a negative number. That's why I will display a message invalid input. If the number is equal to 0, as I mentioned earlier, 0 factorial is 1. And if not both of these cases, then the number is positive, and then I will give a call. In that case, I'll give a call to this function, which will give me the output. Now, when I give a call, as I said, recursive function is a function which calls itself. So if you could notice this, first call was given from outside, recursion factorial num. This function was invoked, and after that, when till n became 1, this function was called from the function itself. So at that point of time, n went on to become n minus 1. So let's start from 5. So if we are considering 5, all right, so factorial of 5, we need factorial of 5, and the execution will go in this way. Okay, so factorial of 5 is something that we needed. So first time here it will be 5, then in second, when the call goes over here, it will be 5 into factorial of 4. So this part will get executed, uh, because at that many times this function will be called, right? So this part will get executed. If you could see in this diagram, the factorial of 5 will be reduced to factorial of 4, then 3, then 2, then 1, and then finally factorial of 0. All right. So in this case, if you would see, the execution goes this way. Okay, so the execution of function calls will go this way, from factorial of 5, then factorial of 4, then factorial of 3, 2, 1, and 0. And while returning the result, or while returning the values, the function call will go the reverse way. That is 0 factorial into factorial of 1 into factorial of 2 into factorial of 3, and then into 4 into factorial of 4 into factorial of 5, in such a way. So to better visualize it, let's take help of Python tutor. So if you could look at this step by step here, then you will get the idea of what I'm trying to explain. So yes, recursive function, the factorial function was created. Then next, if I click next, in num, the variable 6 here. So wait, I'll take it as 5 itself, so that there is no confusion. Hold on, just need to mention 5 over here. Okay, so I've started the execution all over again. Num is equal to 5. If num is equal to, I don't want all this. Yeah, if num is equal to, num is equal to 5, the variable is created. Now it is checking for the next code. If num is less than 0, no. If num is equal to 0, no. So else part will be executed. In the else part, actually what we are doing, we are giving a call to a function. Now once this line is executed, the focus will straight away shift to the function, and whatever the function task is there will be executed. If n is equal to 1, no, equal to 1, no, so else part will be executed. Now here again function has been called, so n minus 1 is nothing but 4, so it will go to 4. Again the function will be called, again the n will become 3. Look at this, n became 3. Again the function will be called, n became 2. Again the function will be called, n becomes 1. And if n, I have a condition, if n is equal to 1, return n, equal to 1, return n. So this time, yeah, look at this, 1 is returned. 1 is returned. Now, so as per our diagram, if you look at the function calls, if you look at the order in which functions were called, from factorial 5, factorial 4, 3, 2, 1, 0 is already completed, this red line. Now the values are starting to return. 0 was not done because we had a condition that if it is 1, return. So from 1 it started returning. Now it will start returning as well as calculating a product. So let's see how it returns. Yeah, so if you look at this, I do a next step. Here value 1 is returned. Next time value 2 will be returned. This is the statement that is getting executed. So current n into n minus 1 is what is happening over here. So again the product will be returned. Then again 6 into 4, 24 will be returned. 24 into 5, 120, and 120 into 5 finally would return. Sorry, 120 was the last number, so 120 will be returned. In case of 6, it will be 120 into 6, and that would have been whatever the number, 12 6 are 72, so 720. All right, so that's how recursion works. So that's all about recursion. And now let's move on to lambda functions. So what are lambda functions? In lambda functions we use a keyword called as lambda. These functions are anonymous functions, meaning that they don't have any name associated with it. So we have taken an example here as well. We will define a function that returns a cube of a number. That is, we will define a lambda function that returns a cube of a number. So if we define normally, this is the way we all know it. However, in case of lambda, we will have to use a keyword called as lambda, and then the parameter that should be passed, that is y, and whatever is to be done will be written after colon. So lambda y colon, and what is here to be done? It is cube. So y asterisk y into y asterisk y. So this will return cube of that number and will be stored in a variable called as lambda cube. So if you pass 5 or any number in that lambda cube, you will get the desired output. So here we have tested for 5. You may use another number as well. It's taking a bit of time to execute the code. You would see here lambda cube of 5 is equal to 125. This is the normal function. This has nothing to do with the lambda function. However, if the same function, if you want to write it in the form of lambda function or in a shorter format, you can write it this way: lambda y, and whatever the function task, that is to take a cube of it, that is cube of y, and store it in lambda cube. So this lambda cube will take 5 as a parameter and return you the result. If you want to try some another number, you can very well do it. Okay, so this is how it is: 216 using lambda function. We did not run the factorial code, so we run the code for factorial as well. We saw it for number 5 and see it is giving you the result. So the interesting part in the recursive function was the execution of it. Wherever the function calls were made, it went in the order from factorial 5 to 4 to 3 to 1, and when the values were returned, it were returned in reverse order, and also returned by doing a product in each and every step. So that's how recursive functions work, and that's how lambda functions work. I hope this would have cleared a lot of doubts, um, as as the session had these simple examples, and I hope this would have helped you. Thank you.